All right, this is Math 209, Week 3. This is section 7.6, and what we're doing is solving rational equations, which sounds fancy, but basically it's just fractions. All right, so the directions say solve, right? So you've got this x over 4 is equal to 2 over 5. And when you just have a single fraction equaling another fraction, we call that a proportion. X over 4 is equal to 2 over 5. And what we know about proportions is that when you multiply these two numbers, you are going to get the exact same value as multiplying these two numbers. So basically what that's saying is, that's saying 5x is equal to 4 times 2. And so really that means 5x is equal to 8. And then we can use division. We'll divide both sides by 5. So the 5's cancel, leaving us with x is equal to 8/5. And that is our answer. And you're going to put that in your little box. So again, we have two fractions. One fraction being equal to another fraction, so that tells us it's a proportion. So we're going to write 2y over 7 is equal to 7y over 2. And we know that the cross products are equal. And so that means 2y times 2 is going to equal 7 times 7y. And so when we continue solving that, you end up getting 4y is equal to 49y. Let's see, did I cut? Yeah, okay. And then we can subtract both sides by 4y, and that gives us 0 is equal to 45y. And automatically we know that y is going to be 0, but we can divide both sides by 45. So the 45's cancel, leaving us with y is equal to 0. So that is your answer. So, whoa, sorry about that. Whoa. So that means y is equal to 0. You are not going to put no solution because y is 0. And again, we have one fraction equaling another fraction, which means we can use our cross products method. So we have 6/7 is equal to 1 over 3x plus 1. And we know that our cross products are going to be equal. So that means 6 times 3x plus 1 is going to equal 7 times 1. And so we're going to have to do the distributive property here. So you've got 6 times 3x and you've got 6 times 1. So that gives you 18x plus 6 is equal to 7. And now we have to solve for x. All right, so when we're solving for x, in this case, the first thing we're going to do is subtract by 6. So the 6's kind of cancel out, and you get 18x is equal to 1. Then we're going to divide both sides by 18. So the 18's kind of like cancel each other out, and you get x is equal to 1/18. And that is your answer. Whoa, gee whiz, I'm struggling there. For your box up there. We have a fraction equal to another fraction, so that means we can use our cross products method. So we know that we've got 8 over 7x is equal to 7 over x plus 2. And because we have one fraction equal another fraction, that means the cross products are equal. So that means we have 8 times x plus 2 is equal to 7x times 7. So we've got the distributive property here. This is not the distributive property because there is no plus or minus sign. So this is the distributive property, so we end up with 8x plus 16 is equal to 49x. And solving this equation, we need to get all the x's on one side and all of the constants on the other. So I think what I'm going to do is I'm going to subtract both sides by 8x. That makes this go away. So we're left with 16 is equal to 41x. And now we're going to divide both sides by 41 because I want that the x to be all by itself. So the 41 goes away and you get x is equal to 16 over 41. And again, we have one fraction equaling another fraction, so that means we can use the cross products method. So you have 6 over y plus 2 is equal to 5 over y minus 4, and the cross products are going to be equal. So that means we've got 6 times y minus 4 is equal to 5 times y plus 2. And we have the distributive property twice. We have one distributive property here, and we have another distributive property right here. All right, so now we're ready to just do that distributive property. So you get 6y minus 24 is equal to 5y plus 10. And now to solve this algebra, we want to get all the y's on one side, all the constants on the other. And so let's add both sides by 24. That makes this constant go away, so you end up with 6y is equal to 5y plus 34. And then we're going to subtract both sides by 5y, and that makes these go away. And so you end up with y is equal to 34. And you are, and we are done. We have a fraction equaling another fraction. So that means, again, we can use that cross products method. And the cross products method, so what do we have? We have x plus 2 over 3x is equal to 4 over 3. And the cross products say that this is going to equal this. And so that means you're going to have 3 times x plus 2 is equal to 3x times 4. And so we have the distributive property, which means we get 3x plus 6 is equal to 12x. And again, I want all the variables on one side and all the constants on the other side. So in this case, it looks like the easiest way would be to subtract both sides by 3x. That gets rid of these guys. Leaves us with 6 is equal to 9x. And we're going to divide both sides by 9. That gives us x is equal to 6/9. But you got to notice that that fraction can be reduced. So x is equal to 2/3. Now how the heck did I get 2/3? Well, I divided both the 6 and the 9 by 3. So that gives me x is equal to 2/3. And we still have one fraction equaling another fraction. So that means we can use the cross products method. So we've got 4x over 4x plus 7 is equal to negative 7 over 4x plus 7. But here's a really cool thing I want you to notice. It's kind of a shortcut. You get to use it every so often. When the denominators are the same, basically, that just means you can ignore the denominators and you immediately jump to 4x is equal to negative 7. You don't get to use that trick very often. So it's nice when you do get to use it. So we're going to divide both sides by 4. That makes the 4 go away. So you get x is equal to negative 7/4, and that is your answer. Now here, this does not look like we have a fraction equaling another fraction, but we do. That fraction right there is really negative z over 1. So we are allowed to use the cross products method. So you've got 25 over z plus 10 is equal to negative z over 1. And there's our cross products that we're allowed to use right there. And so, let's see, in no particular order, I guess we've got 25 times 1 is equal to, and then we've got negative z times z plus 10. All right, and so the left side, straightforward, that's 25. Now the right side, we have the distributive property that we're going to need to do. So you've got negative z times z, so that's going to be negative z squared. And then you've got negative z times positive 10, so that's going to be minus 10z. And so the easiest way to solve this is to get all the variables and all the constants, everything on the left side. All right, so when we do that, I'm going to add z squared to both sides, and I'm going to add 10z to both sides. And so what do we end up with? Well, the right side, this goes, they undo each other, they undo each other. So our left side ends up being z squared plus 10z plus 25, and the right side is 0. All right, so now what are we going to do? Well, this can be factored. All right, so when we factor that, it means we're going to go over here, and that's the thing we're factoring is z squared plus 10z plus 25, right? Was that the problem? Yeah, there it is right there. All right, so, all right, now we're going to use the box. And we know that z squared goes here. We know positive 25 goes here. So that's z times z. We're going to guess 5 times 5. And so our internal terms become 5z and 5z. Now, we want our internal terms to equal positive 10. Well, how do we get these two guys to equal positive 10? Well, it means this has to be positive 5z and that has to be positive 5z, so that makes those positive 5s. So this factors to z plus 5 times z plus 5. All right, so we're going to take that and we're going to go back over here to our problem, and we're going to take this expression and we're going to rewrite it as z plus 5 times z plus 5, and that's equal to 0. So what does that mean? Oops, whoa, sorry guys. There you go. And so what does that mean? It means this number times this number is equal to 0. So that means either z plus 5 is equal to 0, or it's going to be redundant, z plus 5 is equal to 0. So what that means is z plus 5 has to equal 0. Because when you multiply two numbers to equal 0, that means one of those, or both, has to be 0. So now we're going to solve for z. So we're going to subtract 5. That makes the 5's go away, and you end up with z is equal to negative 5. So that's a lot of work for such a simple looking little problem to show that z is equal to negative 5. All right, now we do not have one fraction equaling another fraction. So what we have to do is we have to add these two guys together first. All right, so the first thing we're going to do is x over 5 plus what was that, x over 10? Yeah. X over 10 equals 6. Now the thing we need to know is that we can replace that 10 with a 5 times 2. So what does that mean? Well, this denominator has a 5 times 2, but this denominator only has a 5. So we need to give him a times 2, which means we have to multiply by 2 on the numerator. There's our 1 whole. So now we have common denominators, and our common denominator is 10, or 5 times 2. This numerator is 2x plus this numerator, we didn't do anything with it, it's just x. And that's equal to 6. So what do we end up with? Well, that means 3x over 10 is equal to 6 over 1. So now we can use our cross products method because we have one fraction equaling another fraction. And so you end up with 3x is equal to 60. And we're going to divide both sides by 3. It makes the 3's go away, so you end up with x is equal to 20. Oh, man, that's a lot of work. That's kind of cool. All right, we don't have one fraction equaling another fraction yet, but so we're going to have to add those fractions first. So you have 1 over z plus 2 over z, and that equals 3. Okay, so that equals 3. So we already have common denominators, so we can add. So that's 3 over z is equal to, and I'm going to change this to 3 over 1. And why did I do that? It's so that we can have a fraction equaling a fraction, and now we can use our cross products. So 3 times 1 is going to equal z times 3. So 3 times 1 is going to equal z times 3. So this means 3 is equal to 3z. So we're going to divide both sides by 3 to make the 3's go away. And you end up with z is equal to 1. And that wraps up this entire video.